Welcome back. Let's continue with our lesson. Let's look at the concept map again. We are dealing with algebraic language. We are going to start with rules of writing. A few things that we need to know. The first part is when we say a number in any expression, it represents I've used the y as a variable. It's an unknown number. The value can be any value that would be given or we can calculate. So at this stage, I've just used y as an example of any number. Secondly, the sum of 3 and 8. Most of the calculations we will find they are using sentences that we have to convert into expressions. So when they say sum of 3 and 8, remember sum is representing the addition sign and then 3 plus 8. This is a binomial meaning two terms of that expression. The next one is the sum of a number and 13. We've used n for the number which is unknown. Again, the sum represented by plus and 13, it's a binomial as well. The difference of two numbers, we don't know the numbers, so we're going to use variables for each of the numbers, and it can't be the same variable because it's two different numbers. And then the difference is the subtraction sign between them. And then, 6 subtracted from a sum of two numbers. The sum first of the two numbers, when it's done, you subtract 6 from that. So the order of how that is written is important. It says 6 is subtracted from. When you see the word from, it means that whatever follows that letter, that word from, comes before the one that you are subtracting. So the sum of two numbers must be written first, and then you subtract the 6. And it is a trinomial because x is a term, there is an operation sign, a plus sign. Y is a term, there is a subtraction sign, and 6 is a term. So it's a trinomial, 3 terms. And then the product, the next one is the product of a negative number and two numbers. The word product means they are multiplied together. So you cannot have a plus or a minus sign between them. It's one term. It's a negative number, which is an integer, -7. And then that -7 is the integer, which is negative number. And the two numbers would be B and C. So they are unknown. They are multiplied to 7. And there is no sign between them. It's a monomial, meaning one term. And then 5 subtracted from double a number. 5, as I said, the word from says whatever follows must be written first before we subtract. So the double number means the number is k and we don't know its value, but it will be doubled. Therefore, because it is doubled, it means that it's multiplied by 2, and then we subtract 5 from it, and it's a binomial. All right. Then, now that we are clarified of those terms and how they are called, let's go back to our concept map and look at the next part, which is now coefficients and exponents. Let's continue with that. Here is a brilliant example of coefficients and exponents. In this case, we would like for you to be able to see how an expression is labeled. Firstly, we look at coefficients are the numbers that are multiplied to the variables. They are blue in color, so we are able to see them clearly. And then there are variables x and y, and the variables are the ones multiplied to the coefficients, and their values are unknown. And then there is -9. That one is a constant. It's a number that will not change throughout the expression. It will remain its value of 9. This is an expression that has 3 terms. The first term is 3x, and the next term is 5y, and the last term is negative 9. All right, let's move on then to coefficients and exponents. Here's an expression. In this expression, minus 2x squared plus 3x to the exponent 3 minus x plus x to the exponent 4. What that expression says to us is they all have x. However, the x has been multiplied differently. Let's look at the first one. It is negative 2x squared, which means it is x multiplied by x. So because there's x and x, the outcome thereof is an exponent 2, because there is x to the exponent 1, which we do not write mathematically, but we know it is there. And when we add that one and that one, we have x to the exponent 2. Look at the next part, which is x to the exponent 3. So it will be x multiplied by x multiplied by another x. So then it would be 1, 2, 3. So it will be x cubed. That's how those x's come about. But sorry, our task is to find what is the coefficient of x. So in that whole expression, we look for where x is. There is x, not x squared, not x cubed, or x to the exponent 4. We look at what they asked us to find is the coefficient of x. We look at x, what value has x been multiplied to? And we then see that there is a negative sign. That negative sign is represents negative 1. Therefore, when we say the coefficient of x, we'll then say the coefficient of x is negative 1. We do not write it as just the negative. We need to acknowledge that it is an integer, so it is negative 1. Mathematically, we don't write it, but we know that it is there. The same way that when you speak to a person, you cannot say, please give me 1 cup of water, or 1 glass of water, so that I can drink. You say, give me a cup. They understand that we are speaking of 1. You don't have to mention it. Even in maths, we do the same. Look at the next one. It says, what is the degree of this expression? Degree of the expression says we look for the highest exponent. I have 2, that's an exponent. I have 3, that's an exponent. I have 1 that we are not writing mathematically, and I have 4. So the highest of them all is 4. So then when they say what is the degree of the expression, we say the degree of the expression is 4. We don't say x to the exponent 4, we write 4 as a value. All right. Our next expression reveals that we are not only limited to x, we also have other unknown numbers, that unknown variables that we can use, like this one, where the variable is y. Let's look at the first term. We have y squared, which is y multiplied by y, and that would then give us y squared. Again, y to the exponent 1 and y to the exponent 1, 1 plus 1 then gives us 2. The next one is y multiplied by y, which then gives us y to the exponent 3. So that helps us to understand that in terms of this one, the third term, y is raised to the exponent 1. But mathematically, we don't write that, so we call it y as it stands. So when the question says, what is the coefficient of y, we look for where y does not have a square and does not have a cube, or it does not have an exponent 4. So that is where 5y is. But then we take the coefficient with its sign. So it will be negative 5. We do not just write 5, we also need to write the sign as well. The next question is, what is the degree of the expression? Now, degree, we said we consider the exponents in the expression. Let's go back to the expression. The first one is 2, the next one is 3, and the next one is 1, though it is not written in mathematics, and then the last one is 4. So the highest one of the 4 is 4, therefore that becomes the degree of that expression. And like we said, we write 4 as a value, not y to the exponent 4. All right? Then let's look at the next one. And again, the unknown is not x or y, it's m. So it shows that it can come in any form, but the method is still the same. As long as we look at the term and you realize that it's m squared, it means that m has been multiplied by m to give us m squared. And that helps us. Let's look at the last one. It's m multiplied by m multiplied by m multiplied by another m. Then that gives us m to the exponent 4. So those numbers help us to understand how many times that value has been multiplied by itself. So what is the coefficient of m squared? Which means we go to the expression and we look at where m squared is, and whatever is multiplied with m squared becomes the coefficient. And in this case, it is negative 12. We don't say negative 12m squared, because then with m squared, it's no longer a coefficient, it's a term. But the coefficient is what is multiplied to m squared. And then again, the degree of that expression, now it's easier to follow, because then we look at which one is the highest. We have a 2, we have an exponent 3, we have an exponent 1, and we have an exponent 4. So our answer then becomes 4 again. Okay, let's stop there for now. Let's go for an ad break. I'll see you shortly.